This is skill practice 44, concentration and time. So question 1 asks, given the following reaction and data, answer the following questions. Part A asks, how do the rate of disappearance of NaCl compare to the rate of appearance of Cl2? So if we look at the equation, we'll notice that 2 moles of NaCl are consumed in the reaction to form 1 mole of Cl2. That's the moles of NO aside. We're just looking at NaCl and Cl2. So that means that the rate of disappearance of NaCl is twice the rate of appearance of Cl2. Part B asks whether the reaction is first order or second order with respect to NaCl. And is second order. Then they ask us to calculate the rate constant, K, with units. So because we know it's second order, we know we're going to use the second order reaction equation, which is the inverse one. And we're going to pick just a time off the day table. So at 995 seconds, the concentration is 0.137. And then we're just going to solve for K, plug those in and then solve for K. And K comes out to be 0.00231 over molarity seconds. Then they ask the average rate of the reaction between 0 and 995 seconds. And rate is the negative change in the concentration of the reactants over the change in the time. Now, because average rate is a slope, so you need 2 points, not 1. So we're going to take the 2 points they gave us at 0 and 995 seconds and plug those in. And the rate comes out to be 6.33 times 10 to the negative 5. He asks us to describe how we would find the instantaneous rate of reaction in 700 seconds using a plot of 1 over concentration versus time. So because we know that this is a second order reaction, we know we're going to use this inverse equation to create a linear graph, which means we're going to have to take all the concentration values and take the inverses of them. And then once we can do that, we can plot the inverse of the concentrations and the time on the graph, and we can take the slope of the tangent line in 700 seconds, which will give us instantaneous rate of reaction. Instantaneous rate of reaction is at 1 point, and if you're doing average rate of reaction, you're going to have to do it in an interval. So from like 0 to 700 seconds would be average rate of reaction. Part F asks us to write the rate law for this reaction. So because this reaction is second order, the exponents on the different components of the rate law should add up to 2. So the rate law is basically rate equals K times some concentration to some power times some concentration to some power. All those powers need to add up, in this case, to equal 2. Because there's only one reactant, the power on that reactant has to be 2. So our rate is K times the concentration of NaCl squared. Part G asks us to calculate the rate of disappearance of NaCl at time 1550 seconds, and it comes out to be 3.13 times 10 to the negative 5th molarity over a second. H asks us to calculate the rate of appearance of Cl2 at 750 seconds, which comes out to be 2.54 times 10 to the negative 5th molarity over seconds. Question 2 is aspirin decomposing in acetic and salicylic acid using the following data. So A asks for the order of the reaction, and it comes out to be second order. B is the rate constant. Just like everything we've done, we know what kind of equation we need now. We plug in time off the day table, so at 10 minutes the concentration is 0.46 molarity. Plug it in, solve for K, and K comes out to be 0.1171 over molarity times minutes. And finally, C asks how long it will take for the aspirin concentration to reach a value of 0.2. It's sort of like half-life ones. We have our equation, then we plug in the values, and then we solve for T, which comes out to be 34 minutes. So basically, for anything with concentration and time, you just need to know what kind of reaction you're dealing with, whether it's first order or second order, and you just need to look at the information you have and the information you need to find. A lot of it, as you can tell, is algebra, so it shouldn't be too bad. Just make sure you double check your work and you're not making any little silly mistakes. That's the only thing that could probably be your downfall. But that's about it. Hope this helped.